Hi class, today's lesson is lesson 2-3. We're going to translate between tables and expression. In just this past lesson we talked about translating between words and math. Today it's between tables and expressions. Purpose for today is to write expressions for tables and sequences. There's no vocabulary for today. Let's go ahead and go to our first example. Here we have our first table. It says write an expression for the missing value in each table. As we look at this table, we see the headings on each of these columns: Riley's age and Ashley's age. Here we have Riley's age is 9, Ashley's age is 11, Riley's age at 10, and Ashley's age at the same time would be 12. So as I'm comparing these ages, I'm seeing that when Riley, who seems to be the younger, is 9, she's actually 2 years younger than Ashley. When I go down this list, it asks me, well, what's Ashley's age when Riley's age is any age. So how do we get from 9 to 11? Well, we have to add 2 here in order to get Ashley's age. We have to add 2 to 10 to get 12, Ashley's age. So if Riley's age is the variable n, how old is Ashley? Well, if this goes for each one of her ages, 11 plus 2, 13, 12 plus 2 is 14, then it makes sense that that would be the rule and the expression. So the expression would be written n plus 2. Ashley's age is Riley's age plus 2 is what that means. Here we have another example. We have eggs over here and dozens. How many dozens? As I look at this, how do I get the number of dozens based upon the number of eggs? I look at the first one and I see there's a 12 eggs equals a dozen eggs, 1 dozen. I could do that possibly by subtracting 11. So let's see if that works for number for 24 eggs. 24 subtract 11 does not equal 2, so it's not a subtraction operation. Let's go try division because we know it's getting lesser. So let's try divided by 12. 12 divided by 12 equals 1. How about 24 divided by 12? Well, yep, that equals 2. 36 divided by 12, yep, that equals 3. 48 divided by 12, that equals 4. So if I had an E number of eggs, how would I find out how many dozen eggs there were? Well, it looks like I just have to divide by 12. Another way to write that would be E over 12. Next, we have another table. This time, it's just written horizontally rather than vertically. Let's take a look at the expression that they want here based upon the n, its position. So we have in the first position a 3, in the second position a 5, etc., etc. To get from the 1 to the 3, I can see adding a 2. So is it n plus 2 that gives us that value of the term? 1 plus 2 is 3. 2 plus 2 is not 5. So obviously that is not what we need to do. We are increasing from the position to the value. So let's try multiplication. So if we try times 3, 1 times 3 is 3, great. 2 times 3, unfortunately, is 6. It's not 5. So that leads me to believe there may be 2 operations involved here. So the next thing I'm going to do is I'm going to say, well, let's double the 1. 2 times 1 is 2, and then add 1 to make it 3. So 1 times 2 is 2, plus 1 is 3. How about if we multiplied this by 2? That'd be 4, plus 1 is 5. 3 times 2 is 6, plus 1 is 7. Great, it works for these three. It's got to work for all of them. So we're going to go ahead and make sure that it does. 4 times 2 is 8, plus 1 is 9. 5 times 2 is 10, plus 1 is 11. So what we have is multiplying by 2, n times 2. I'm going to write that as 2n plus 1. That's our expression. And notice that this is the first expression we encounter that actually has 2 operations inside of it. So for the position, let's say n would be 100. If it was 100, what would the value of that term be? Well, if we found what the 100th number was, it would be 100 times 2 is 200, plus 1 is 201. So the value of the 100th term is 201. This expression is pretty powerful. Let's go to the third example. Here we have a triangle. A triangle has a base of 8 inches. Let me go ahead and pull this over. Base of 8 inches. Now the table shows the area of the triangle for different heights. There's the area. There's the heights. Write an expression that can be used to find the area of the triangle when its height is 8 inches. So let's take a look at this first one. This is our first one, and this has a height of 1. So I'm going to write down the height here is just 1. Next, this is a height of 2, so I'm going to stretch this a little bit. And I'm going to imagine that's 2. And you see how the base remains the same. It is still 8, base in inches. It's going to be constant. It's just the height that changes. Here I've got a third one. Base is going to remain the same here, yet I'm going to extend that height, and we'll call that 3. So we have 1 inch height, 2 inch height, and a 3 inch height here. And those 2 little tick marks there mean inches. So if we have a triangle that's an h height, any height, what would the expression be over here? Well, let's find out the relationship between the height here and the area over here. When we go over to this, we see that we have an 8 and a 1, and we get an area of a 4. Here we have a height of an 8, and our area is 8. Base here is 8, height here is 3, and we get a 12. So it's not 8 times 1 doesn't equal 4. What do I do in order to get there? Maybe it's 8 divided by 2? Just the base divided by the height. 8 divided by 2 is 4. 8 divided by... that doesn't work. So I'm going to have to somehow use the base and the height in order to get the area, in order to derive the area. So I look at this more closely, and I say, well, if I multiply these two numbers, 8 times 1, how do I get down to a 4? 8 times 1 divided by 2. Okay. Will it work here? 8 times 2 is 16. Divided by 2 is 8. Great. 8 times 3 is 24. Divided by 2 is 12. 8 times 4 is 32. Divided by 2 is 16. So it looks like it's base times height divided by 2. So I am simply going to go ahead and write, in this case, the 8 which is the base, times the height, which is the h. Now I'm going to divide it by 2. I can either write it like this, or I can write 8 times h divided by 2. All right. We can see in this problem as well, there are 2 operations, multiplication and then division. Finally, here's to complete the problem. This should be pretty easy for you to figure out, but I want you to go ahead and draw this table out and figure out how do we get the correct expression inside of this block. We have to look at the go-karts, number of go-karts, number of wheels, in order to get the expression which represents the number of wheels. All right, we'll see you in class.